Okay, so this question we're going to search in a sorted array of unknown size. So it's just like any other normal search in a sorted array question, only that we don't know the array size. We can only access the elements in the array using an array reader interface. So, um, and are the elements in the array unique? Yes. So we can, by observation, we can see these arrays as some special arrays, always with the maximum integer on its right. So let's say an array could be something that's smaller than the target, smaller than the target and equal to the target, and bigger than the target and bigger than the target, and then some maximum integer and maximum integer. Or it could be like bigger than the target, bigger than the target, and then maximum integer and maximum integer, or smaller than the target and smaller than the target and maximum integer and maximum integer. So these are the some possible scenarios, but what they have in common is that they always have maximum integer on its right. While maximum integer, because we already know the value domain of the input array, so we can be sure that this maximum integer is definitely larger than our elements. And because obviously this array is sorted, so we can use binary search to get our result in logarithmic time with constant space. But problem is we don't know anything about our search space. So we can do this in two steps. So step one, to explore about the search space, and step two, after we've already know where, like, what our search space is like, do binary search on this search space. So that is basically the idea. Um, and as for exploring the search space, mm, we can start from a length of 1. As we know, the minimum length of the array will be 1, so we can start from length 1 and then expanding the search space, and we can shrink the search space later in a step 2 binary search. Well, as for the search space, we just need to make sure that, let's say, our search space is defined by is an interval with left and right boundaries, like this closed interval. Then we just need to make sure that the the elements index left must be smaller smaller than or equal to the target, while the element on the index right must be bigger than or equal to the target, right? Or else um, we are sure that the target cannot be in this interval. So we just need to make sure of that. And so I think what we can do is first, as for the left boundary, we can check the the first element in the array. If the first element is already larger than our target, then we can be sure that the target definitely does not exist in the given array. And also, as for the right boundary, we can keep expanding it by always times, like always double its value, double the right index value, until we can find a place where its value is larger than or equal to our target. And actually, we're sure that we can get to the point because, as I said before, in this case, we can see all our input array as arrays with maximum integer on its right. So we can always find a place where its value is larger than our target, so we can stop when that happens. And that is when we can stop expanding the search space and start the ordinary binary search procedure. Yeah. And that is the general idea. And because for both the steps takes log n time, so in total this algorithm will take log n time. So does that sound okay to be code? Well, alright. I think that's okay, and I'll just start coding. First, I think we have a class solution, and this should our, so find, we're given an array reader interface and a target value. So first of all, we can do some sanity check for our input. Oh, actually, it's fine. Yeah. So actually we can check if the reader, if the first integer is already larger than the target, then we can just return -1, and then we can expand the search space, make the right as, so we will initialize the right pointer to 1 and keep expanding it until we find a element's value that is larger than or equal to our target. So until so when the element value is smaller than the target, then we definitely will miss no, not definitely, but we might miss out our answer outside of the search space. So we have to keep expanding it. So while the element at right is smaller than the target, then we will expand the search space by double right. Yeah. And then we definitely will stop somewhere. And then do binary search. So we can put the reading and the target inside. And then next we just write a normal binary search. And int target. No need for any sanity check. So initialize the left boundary pointer to 0 and the right boundary pointer to wait here we should give the right boundary here. Yeah, right boundary. Right. And then while gets the mid value so the current value would be reader get mid, and then compare the current value with the target. If they're equal, then just return the mid value. Else, if the current value is smaller than the target, then move the left pointer to mid +1 to look for the answer in the right half, or else move the right boundary to mid -1 to keep looking for the answer in the left half. And if we're already out of the loop and haven't found anything, then the target is not in the given array. Yep, and this should be it. And let me check if there's any error. Find if it's larger, and just return -1. And if it's smaller target, here we've already found it. And then binary search, given the reader and target. Left +/-1. Yes. Okay, I think that should be fine. And yeah. Well, next, let me try some example on the code. So, well, for example, the let's just take this as an example. Um, so the array is -1 and 0, 3, 5, 9, 12, and target is 9. Okay, and here, if so, reader is the first element is -1. Is it larger than target? No. Then we continue. And here right is 1. And reader gets right is 1, so it should be 0. And is this more than target? Yes. Then right will double, then it will become 2. And its element will be 0, 1, 2, it will be 3, and it's still smaller than the target, then it will double again, and 0, 1, 2, 3, 4, and it will be 9. And then now it's no longer smaller than the target again, so here we will have right is 4, and so left is 0, smaller than or equal to right, and here met will be 2, and current value will be, well, let me check, 0 and 2, so it will be 3, and 3 is smaller than target, so left will be mid plus 1, which is 3, and now left so mid will be 3 again. Is that it? Yes, 3 again. So 0, 1, 2, 3, 0, 1, 2, 3. Okay, so it will be 5. Current value will be 5, and it's still smaller than the target, so left again will be mid plus 1, which is 4, and mid will be 4, and so 0, 1, 2, 3, 4, it will be 9, and it's equal to the target, so we just return mid, which is 4, and is this our answer? Yes. Okay, let's try something else. So let's say if the array is like this, then we will return -1 here, and it's fine because and I think it's true because I think it's right because the smallest element in the sorted array is already larger than our target. Then what it means is that all the elements in the array are larger than our target, and which also means that it's impossible that our answer could be in this given array, so we just return -1. Yep. And if it's like this, let's try this. So at this point, right will be 1, we will not return -1 here, and here right will be 1, and is is the reader, the element at right, is this smaller than target? No. So we won't get into this loop, and here we will give our right boundary as 1. So left will be 0 and mid value will be 0. And so our current value will be 0 as well, and 0 is smaller than the target, so left will increase to mid plus 1, which is 1, and at this point we won't get into the loop anymore. Oh, no, we will. So minus, because left is equal to right, so we will get into the loop, and mid will become 1, and then at this point current value will be max integer, and it definitely is larger than the target, so right will decrease to mid minus 1. Okay, so it will become 0, and then at this point left is already larger than right, so we won't get into the loop, and we haven't returned anything, so we will just return -1. And I think it's correct because it doesn't exist in the array. So yeah, so that should be it.